Hello flatties and globe defenders, it's Critical Thing from Down Under. And oh my goodness, Phuket word, what are we going to do with you? Your latest video is a really nice piece of work, but unfortunately, let's say you show a little bit of inadequacy in your understanding of geometry and perspective. And I'm looking to correct you on this. Now you do say, well, if we think you're wrong, we should prove it. And I've done so on a number of occasions, but you seem to have ignored everything that I've done so far, and maybe you'll ignore this. I don't know. But I think you may be afraid of me. You've actually blocked me from your channel because I guess I'm making a little bit too much sense there. And I tell you what, I can come over to Phuket in February and we may be able to get together and talk about perspective and geometry, and I might even be able to show you how to find the curve. What do you reckon?
Hello, Flat Earth researchers, debaters and debunkers. Perspective is the imaginary curve of a globe Earth. Perspective's also angular size. It's the same thing. And of course we're taught that we are smart to be able to imagine ourselves on a spherical Earth. We can all perceive that, and we can believe it. But it's never been proven.
What? Never been proven? Have you looked? Anybody see any proof of the globe anywhere? Well, I know. See? None exists. I told you so. Well, here's something. For example, what about this? Every day there are about 100,000 flights. And barring tragic accidents, every one of them reaches their destination using navigation based on a globe. Evidence of flat Earth navigation, anyone? Didn't think so.
Everything rises to eye level because of perspective and because of angular size.
Nope, wrong again. Not everything. The horizon in this picture does not rise to eye level. This camera is at 24 meters above sea level. The ship is at sea level. The horizon is near the bottom of the ship. Therefore, the Earth is not flat. Very simple.
The only way we can justify this happening on a globe Earth with this side-on view is to have the observer looking down. We are told that we look down to the horizon, and that's why there's always such an argument about the higher you go, the further you look down, and people end up arguing about refraction, diffraction, and differences of fractions of degrees in some alleged drop of the horizon. But the fact remains that the surface and the sky always appear to meet in the middle of our field of view because of perspective.
Okay, I've listened to this and I've had a lot of trouble working out exactly what he's saying. I'm trying to understand what he's trying to say, and I think I have worked out what's inside this flathead. So I'm going to talk about what the real meaning of eye level is. Now, eye level is an horizontal or level tangential line at the height of the observer eye. Now, it's not where you look. I'm pretty sure that Phuket word is confusing where you're looking with eye level. So the definition of eye level is a level at the same, it's a horizontal line, and then when you're on a globe Earth, it's tangential to the surface. So on a globe Earth, the surface will fall away from that line. On a flat Earth, the eye level will remain a constant height above the surface. And this is how you can determine the difference between flat and curved. And I'm pretty sure Phuket Word understands that at some level, but he seems to be confusing it an awful amount. So if we go back to the picture that here demonstrates clearly the difference between curved and flat. Now, the observer, which is me and my camera, is here 24 meters above sea level. Now, if the Earth is actually flat, then the eye level would still be 24 meters above that flat surface, which is the ocean. That's if it was flat. It's not flat, I'm just saying if it was flat. And therefore, on this diagram, if the Earth was flat, the flat water would continue on. It would not curve away. It could continue on, and you would see it all the way to the distance up to that line. But you don't. Now, the other thing here is, I've assumed in this diagram that the Earth is flat. But the diagram shows me that that assumption is incorrect. So this is how you test your assumptions. You can assume something, test it out, find it to be right or wrong. So when people say we assume the globe and always get the globe answer, it's not, it doesn't work like that. As you can see, I assume flat here and I've got globe answer. And if it was flat, if the Earth was flat and you assumed globe and you did the calculations, you'd get flat answer. That's just the way it works. And this assumed globe business is just another thought experiment, crazy thinking, not based in any reality. It's just based on crazy thinking. And there's because this is now curved, this line here that I've actually drawn on this photo is not at eye level, because there's curvature drop on that 13 kilometers from the observer to the ship. Now, I haven't worked out the exact curvature drop, but it's several meters. And so that's actually not the eye level. Now, I think where Phuket Word gets confused is where he says, now it's a bit of a circular argument, he says eye level is where the water meets the sky. That's the vanishing point, that's the horizon, so therefore that's eye level. And so therefore you're never looking down at the horizon because you're always looking at it. You can just look at it and declare that as eye level. So you cannot, I'm just trying to get my own head around this. So where the water meets the sky is eye level. So you cannot look down at the horizon because by definition it's at eye level. But of course that's not the real definition of eye level. So this has prompted me to propose my own law of perspective. Critical think's immutable law of perspective. And it's this: perspective cannot change the geometry. It just cannot change the way things are. So a little bit more simply, looking at a thing does not bend reality. And you'll see that this is what a lot of flat thinkers try to do. They try to make perspective do something that it cannot. Perspective is simply a way of looking at something. It is the way you see it. It is just a projection of reality, 3D reality, onto a 2D screen, which is your camera or your eye, it cannot change the geometry of things.
And then you look straight ahead. Yeah? The surface and the line of sight are never ever going to meet. Even and especially if the surface is curving down and away from you. And if you are to perceive that you're on a sphere, then you will always be on top. Because there is no up and down in space, right? So there is no looking down to the horizon.
Huh? But you just said you have to look down at the horizon, and now you say, but there's no looking down? Oh, why? How do you understand this? Is this got something to do with the fact that the horizon is supposed to be at eye level, and so you can't look down at it because it is by definition at eye level? Oh, I'm so confused.
But essentially we know that the laws of perspective dictate that anything above the line of sight, which creates the horizon,
No, the line of sight does not create the horizon. The horizon is where the surface meets the sky. The vanishing line and the horizon are different. They often are the same place because it looks like that, but they are different. They are not the same. Phuket word cannot wrap his flat brain around that, and I doubt if he ever will.
So, of course, the problem people will have when they're trying to say that something like the sun will never set on a flat Earth is they take this side-on view and they forget to factor in perspective. They forget to factor in angular size. When we get this side-on view, look what's happened to the house as we get further away, or the house gets further away from us, or whatever this object might be. If our direct line of sight is in the center, it will remain in the center of that. So, of course, it appears to be floating.
Of course it appears to be floating. That's because you've drawn it wrong, you numbnut. No, you don't account for perspective when you're drawing something in a side-on view. Perspective is only the way you look at something. It does not exist in a side-on view. Just perspective does not change the geometry. Perspective is already built in, as I can show you here. So here I've drawn the house in the distance at the right size. Now you can see that the angular size of the near house, which is represented by the red lines, is much bigger than the angular size of the further away house, which is the green lines. And this is why they appear to be smaller. The house with the green lines occupies a smaller amount of your field of view. And so the house close by looks bigger because it occupies a far bigger field of view, and the house in the distance is a fraction of the field of view of the other one. So that's what makes it look smaller. You don't need to draw it smaller on a side-on view. That's incorrect, false. That's just plain wrong. And I'll move to the next picture here. So this is why the house in the distance, another illustration of why it looks smaller. Look at the relative size of those two houses. Now, it's only because of the way you see it. The house is not smaller in the distance. It doesn't change the geometry. And here's the other thing about the ground. You can see now when you're looking down at the bottom of the first house, the red line is looking down. and on the bottom of the further away house, you're looking further out into the distance, and this has the optical illusion of the surface rising. The surface does not rise. The correct way to draw it is the way it is. You do not have to account for perspective when you draw side-on view. That's just plain wrong.
So when we want to represent that in a side-on view, we have to do this. But of course, no one ever does this. We have to have the surface as well, rising up to eye level. And we have to have whatever's in the sky appearing to converge and angle down. And this, of course, is angular size. The house is changing size. It's appearing to get smaller and smaller in the distance. And so is the surface. So are the clouds. So is the anything else in the sky.
You mean the sun, don't you? I mean, that's what you're about to say. That's something else in the sky.
People will demand that the sun changes size.
Yes, of course we do. You just said you expect anything else in the sky to get smaller.
But that's a light in the sky. It's not a physical object. It's not the same as a house, and it's much, much larger than anything else we can compare it to. So arguments about the sun are irrelevant.
So, with a wave of the hand, just like that, you can get rid of the whole sun just has to get smaller thing. Even if it was a light in the sky, why doesn't that mean it doesn't get smaller? Every time I look at a light that's far away, it gets smaller.
It does obey the laws of perspective because it does appear to sink down to the horizon.
Whoa! You mean it does obey perspective, but it doesn't get smaller?
And when the sun gets to about here on the horizon, when it's far away, well, of course, half of the sun is cut off by the surface rising to our eye level.
Whoa, this actually makes my brain hurt. Oh, not only does the sun not get smaller, it goes lower to the ground due to perspective, and the ground rises up to cut off the sun. Ah! I think I'm going to have to go to something a little bit more sane. I've constructed a very simple game level in the Unreal Engine just so that I can demonstrate this perspective thing. Now, this game engine works in perspective because it's designed to reflect reality, and so I have 3 blocks. You can call them houses, and you can notice that, of course, due to perspective, the furthest one looks smaller. If I go out and take a side-on view, there's no sloping ground. The side-on view, they're all the same size. So you do not have to make perspective happen in a side-on view. That's just not on. Perspective only happens because of the way you look at things. So we'll go and we'll verify, yes, that it all seems to work fairly well according to perspective, like the horizon is rising to eye level. The further blocks are getting smaller, even though they are the same size. And you can see I can show that they get smaller no matter which way you look at them. So clearly they are the same size. Now, this is not an infinite plane. This plane here has an edge to it. So it only goes so far. So it doesn't go off to infinity. So the horizon is not going to be exactly to eye level. But at this ground level here, it's close enough to eye level because we're right near the ground, so to speak. So we're down as far as we can go. Now we can watch what happens as I raise the camera. So we can raise up. Now you'll notice, now this, you can hardly see it, but the vanishing point is in the distance. There's a lot of white where the floor is, and then there's some clouds, and you can see there's a line across the screen. But the interesting thing is the edge of my plane, which does not go right into the distance. You have to look down to put it in the middle of the screen. Now let's, so that shows that the eye level and the vanishing point is not the same thing as the visible horizon. Now I'll go down to ground level again, and we'll line this up so that it's at, the camera is pointing at the middle of the screen. Now, just as another illustration of something, if I tilt the camera up, you can see the horizon drops within the field of view, but that doesn't change where the horizon is. You'll also notice that the horizon stays in the same place relative to those blocks. If I tilt the camera down, now all the way down, the horizon is still at the same height up those blocks. Nothing changed. The geometry doesn't change, just tilting the camera. So this is a very important point, and one that seems to have been missed by some people. So we'll level the camera again. So it's the horizon is in the middle of the camera. We raise the camera, and look at that. You can see in the distance that there is a vanishing point in the distance. This game engine provides one, but the horizon is below. Now, if this was a curved surface and it was curving away, then you would need to look down at the horizon. Now, I'm not going to look down just yet. I'm just going to go down, come down again, and you can see the horizon still comes to eye level when you're down near the ground. Again, when you go up, 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 the horizon drops. Now this is a fairly close horizon, but it's deliberately close so that I can illustrate the point. The further away the horizon is, the less noticeable this drop is. So when you go up, yes, you do have to look down to see the horizon in the middle of the camera. It's very simple. So when the Earth is curved, and it is, then you need to look down at the horizon, but it's only a tiny little bit. You can hardly even notice it. So I can understand why people might think that the horizon is always at eye level. This is just something that you might think, but it's not true in reality. And so I don't know what else there is to say with this, but there, if you look along the top of the, oh yes, I know one more thing. If you look along the top of the blocks there, it's hard to get the camera exactly. Yes, they're all lined up. Now, we go to the end of our world here. This world is flat and has an edge. It's also a square world, and not a pancake pizza, or if you like. But there's the edge, and that's it. Well, what I'm trying to do here, you can guess what I'm trying to do here. I'm trying to see if this particular game engine has an angle of attack in it. The so-called angle of attack. And oh, I don't think so. Look at that. Oh, you can see the bottom. You can see the bottom of the furthest block. It's not magically cut off. So this mythical angle of attack is not built into this engine, and probably for very good reason. I would suspect that such a thing does not exist. And so there you have it. Perspective is a function of the way you see things. You do not have to account for perspective in when you're doing geometry. Geometry is different. Geometry tells you what you're going to see and how you're going to see it, whether you're going to see it. If you can draw a line between 2 points, you can look down that line and see something. Nothing else magically happens. So when I draw a line along this floor, as you can see, I can see along the floor. So this is guaranteed to be a flat floor because that's the game engine has done that. But there, looking, the geometry says you should see that far block. The game engine faithfully reproduces it. And remember, these game engines are designed to be realistic. They're designed to make you think you're in a world of reality where everything behaves like the real world. So that's the end of my demonstration there. Thanks for watching, everybody. Can you please help me eradicate this flat earth virus by subscribing and sharing? Thanks very much. We'll see you next time.